Lesson 1. What are the processes occurring in cold environments? What are the processes of glacial erosion? Glacial erosion tends to occur in upland regions and is carried out by two main processes. Number 1. Abrasion. This occurs when the material the glacier is carrying rubs away at the valley floor and sides. It can be likened to the effect of sandpaper or a giant file. The coarser material may leave scratches on the rock known as striations. The finer debris smooths and polishes rock surfaces. The debris involved in abrasion is often worn down by the process into a very fine material, known as rock flour. 2. Plucking involves the glacier freezing onto and into rock outcrops. As the ice moves forward, it pulls away masses of rock. Plucking is mainly found at the base of the glacier, where pressure and friction often result in the melting of the ice. It is also marked in well-jointed rocks and in those where the surface has been weakened by freeze-thaw action. Plucking leaves a very jagged landscape. There are two other processes associated with glacial action that produce the debris glaciers use in erosive action. Both of these are weathering processes. Freeze-thaw action, or frost shattering, occurs in areas where temperatures rise during the day but drop below freezing at night for a substantial part of the winter. Water which enters the cracks in the rocks freezes overnight. The ice occupies more space than water, just under 10%, and therefore exerts pressure on the crack. As the process continues, the crack widens and eventually pieces of rock break off. On steep slopes, this leads to a collection of material at the base known as scree. In a glacial valley, much of this material falls from the valley side onto the edges of the glacier, and some finds its way to the base of the ice via the numerous crevasses which cross the glacier's surface. Nevation is a series of processes that operate underneath a patch of snow, leading to the disintegration of the rock's surface. There are a number of major landforms which are mainly produced by glacial action. These include cirques, arêtes, corries, pyramidal peaks, glacial troughs, hanging valleys, and truncated spurs. So how do glaciers move? Ice movement is complex, and several types of movement can be identified. The main types are, number 1, compressing flow, which occurs where there is a reduction in the gradient of the valley floor, leading to ice deceleration and a thickening of the ice mass. At such points, ice erosion is at its maximum. 2. Extending flow, which occurs when the valley gradient becomes steeper. The ice accelerates and becomes thinner, leading to reduced erosion. There is also basal flow. As the glacier moves over the bedrock, there is friction. The lower ice is also under great pressure, and this combined with friction results in some melting. The resulting meltwater acts as a lubricant, enabling the ice to flow more rapidly. Surges also occur from time to time when excessive buildup of meltwater underneath the glacier leads to the ice rapidly moving forward, perhaps by up to 250 or 300 meters in one day. Such surges represent a hazard to people living in glacial environments below the snout. Internal flow also occurs where ice crystals orientate themselves in the direction of glacier's movement and slide past each other. As surface ice moves faster, crevasses develop. Internal flow is the main feature of the flow of polar glaciers, as without the presence of meltwater, they tend to be frozen to their beds. Creep also occurs when stress builds up within a glacier, allowing the ice to behave with plasticity and flow. It occurs particularly when obstacles are melt. Rotational flow occurs when the corrie, the birthplace of many glaciers, here, ice moving downhill can pivot around a point, producing rotational movement. This, combined with increased pressure within the rock hollow, leads to the greater erosion and over-deepening of the corrie floor. Within a glacier, there are different rates of movement. The sides and base of the glacier move at a slower rate than the center surface ice. As a result, the ice cracks, producing crevasses on the surface. This also occurs where extending flow speeds up the flow of ice, and where the valley widens or glacier flows from valley to a plain. Glacial transportation and deposition, as well as eroding the rock over which it flows, a valley glacier is also capable of transporting large amounts of debris. Some of this may be derived from rock falls on the valley side. It is then transported on the surface of the glacier, known as superglacial debris, or buried within the glacier, within the ice, known as englacial. Material found at the base of the glacier is known as subglacial and may include rock fragments that have fallen down crevasses and material eroded at the base. The huge amounts of material carried down by the glacier will eventually be deposited. The bulk of these will be the debris released by the melting of the ice at the snout. It is also possible for the ice to become overloaded with material, reducing its capacity. This may occur near the snout as the glacier melts, or in areas where the glacier changes between compressing and extending flow. Material that is deposited directly by the ice is known as till or boulder clay, although the latter term tends not to be used today. Till is used to describe an unsorted measure of rocks, clay and sand that was mainly transported as superglacial or englacial debris and deposited when ice melted. Individual stones tend to be more angular to subangular, unlike river and beach material, which is much more rounded. Till affects the character of the rocks over which the ice has passed. In the till of South Lancashire, for example, it is possible to find rocks from the Lake District, such as Shap granite, and southern Scotland, for example, rhybikites from Elisa Crag in Firth of Clyde. In the till of East Anglia, there are pieces of granite from southern Norway. This indicates not only the passage of ice, but the fact that the sea level must have been considerably lower to allow the ice to move over the area that later became the North Sea. Sometimes it is possible to find a larger block of rock that has been moved from one area and deposited in another, which has a very different geology. Such features are known as erratics. There are two types of glacial deposit. Number one, lodgement till, subglacial material that was deposited by actively moving glacier. A drumlin is a typical type of feature formed by this material. 2. Ablation till, which is produced at the snout when the ice melts. Terminal, push and recessional moraines are typical features produced by ablation till.